3.8, again, applications. If we see that, we know that we're looking at word type problems. And I guess, some applications would be, maybe this is a little bit more, applicable, but, so in life, it's rare to see things form straight lines exactly on a graph. And so we're gonna see some that kind of what we call a scatter plot. It's statistical or probability based, but they essentially can form linear relationships. All right, so a scatter plot is just a graph, but they're not gonna really connect the dots, right? So usually it's in quadrant 1, by the way, because all the values are positive. And there's a lot of real life applications where you can't really go into negatives, right? So you got your X and Y axis. They'll be labeled, of course, but then, sometimes there's just kind of a bunch of dots in there. And what we kind of expect with these, the ones that we're going to be looking at, is that they should form some kind of a straight line relationship like we see right here, okay? So like if I looked at this graph, you could say, just generally speaking, we could kind of draw this line right here to represent those dots, those points, those coordinates on the graph that were placed there. And whatever the data represents, then we say that this line represents all of the data. And that should worry you, by the way, because it's like, what happens if you got a dot out here?
Aren't those called outliers?
Yes, yeah. So you do have outliers like this. And it's like, well, do you include that or do you not include it? And sometimes it goes beyond just a statistical question. Sometimes it's more of a moral question, really, because it's like, look, if we're going to treat people like the average like this, then what does that say about everyone? And then you kind of expect everyone to just kind of fall in line, if you will. So yeah, like I said, most real world data doesn't fall perfectly on a line. Sometimes it's not even a straight line, which is fine. But when we start looking at lines that best fit the data, that's called the line of best fit. Seems like it has another name, but it slips me right now. So now there's a formal way to do this, and if you want to figure that out, take a statistics class. But for now, we're just eyeballing this stuff, okay? Now that means that we got to be close to the points that we're looking at, and when we draw our line, it has to be close, okay? We'll kind of demonstrate that, but the Y-intercept should represent the beginning value, and slope represents the rate of change, how much things are changing. Usually it's in respect from Y compared to your X's. And so again, it's Y compared to X like this because it's rise to run. Okay, maybe I should have written that like a fraction like this. Yeah, so scatter plot, that's what I was thinking. Scatter plot kind of represents all of the points on the graph, and then you put your line of best fit in there. All right, so here we go, something like this. Okay, now the nice thing about these is they're going to give us the function to start out, right? So we got our function right here. They say the statistician, someone calculated this for us. Very, very nice of them. Thank you. Use the model to estimate f of x when x is 8. So if it's saying f of x when x is 8, we're really looking for f of 8, which we've seen this notation before. But we're solving for f of 8 with that function that's already written for us. So 0.45x plus 18.97. And I'll try to color code this. The 8, right? That's the x value. So the x I'm going to replace with 8. Boom. There you go.
So,
all right, so from here, it's just old-fashioned order of operations type problem. I mean, your calculator knows how to do that too. But when I put 0.45 times 8 in my calculator, I got 3.6. And then, of course, we'd still have to add the 18.97, which when I put that into the calculator, I got 22.57. So we don't know what this represents. I mean, it'd be nice to know, but they're not really telling us what the 8 represents, and we now don't really know what this 22.57 represents. It did say it around to the nearest thousandth, but we see this number only goes into the hundredths, so there's not any need to put like a 0 right here. I think on the homework, if you did, you'd be fine, but I don't really see the use, and it's more work than I really want to do. All right, so again, this goes way back when they're like, here's a formula, here's x and y values, now replace those x and y's with numbers. It's just written in a different way with this function notation, that's all. So on this one, a study at a certain restaurant found a linear relationship between outdoor temperature and average number of cups of hot chocolate sold. Now just think about that sentence right there. Hopefully that kind of makes sense that that would happen, right? Like if it's colder outside, you'd probably sell more hot chocolate. If it's warmer outside, probably not as much, right? The relationship can be approximated by the following linear model, which is just the function, by the way. So linear models, of course, we know those can be shown as graphs, but they can also be shown just as pretty much straight equations or functions like this. So X is the outdoor temperature, so that's nice. They're telling us this much. In Fahrenheit, by the way. And C of X is number of cups sold. So C for cups, X for Fahrenheit. All right, so what does the slope represent? Oh, we don't even have to solve anything right here. All we got to do is say what the slope represents and then what the y-intercept represents. So it'd be nice for us to identify first what the slope is, and the slope here is just the coefficient of x, negative 0.955. I'm going to write a sentence for this, although I think on the homework it's just kind of a multiple choice kind of thing for you to figure out what that represents. Okay, so what does the slope represent in this case? Now, over here, slope should be rise over run, right? So you could even say it's negative 0.955 over 1. It's just, what does it represent? Well, it said, so the number of cups sold, that's our y value. It's just shown in function notation. So that'd be negative 0.955 cups. And then the 1, since I made it a fraction, the 1, remember it's always y's over x's. So the 1 right there would have to, we know that the y's are cups, and then the 1 here would have to be, I'm going to put degrees. I'm not going to spell Fahrenheit, not because it's so long, but because I really don't know how to spell it. So degrees, maybe degrees, F for Fahrenheit. There we go. So let's go ahead and write this out then. So the slope, what does it represent? Let's go ahead and put something in here. The negative, by the way, for our negative 0.955 means that the cups sold will drop. Again, that's addressing the negative part of it. 0.955. I'll put 0.955 for every 1 degree. Here we go. Fahrenheit. It should spell check. Oh, there it goes. Boom, I did it. 1 degree Fahrenheit, and that 1 is positive, by the way, so I'd say 1 degree Fahrenheit increase, if I could just spell that right too, okay? So that right there is what the slope represents. Is there different ways to represent that? Yeah, but I'm just using strictly the numbers that was given. And again, you can always put something over 1. And slope should be a comparison of 2 different values because it's a rate. And a rate compares 2 different values, in this case, cups and degrees Fahrenheit. The next thing here is the y-intercept, which is just the plus 99, which on a graph would be 0, 99. It's 99. 99 what? Well, we know that C in the end ends up being cups, so it'd be 99 cups. See, it's a y value here, so it should just represent whatever the y values represent, and they told us up here it's number of cups sold. Now, more specifically though, because it's 99 cups, but remember the ordered pair has the 0 here. It's 99 cups of, I should have typed this out, of hot chocolate. You're gonna have to make this smaller to make it fit. But it more specifically, when the temperature is 0 degrees Fahrenheit. Sorry, that got kind of small there at the end. So with the y-intercept, I want to also address both things, right? Cups and degrees, because it's built into the ordered pair, and then slope as well, because it's a comparison of the two as a ratio. So this also means that if you kind of reverse the negatives, right, that means that if it went down 1 degree in Fahrenheit, you'd expect to sell almost a whole extra cup of hot chocolate at that point. Now you should be able to think, well, is it always going to be linear like that? Probably not. maybe Fridays there's more or something like that. But this is just using the information that they gave us. I don't know, maybe you guys don't even want to think about it in nonlinear terms as well, but I think we'll see that in a future module. If the temperature will be 21 degrees, what would be your expected cells within, so you get to be within $30, it looks like, either way. So, 21 degrees, the first thing, it'd be nice to see where 21 fits in on the graph, and it's degrees, right? We see that the x-axis is representing temperature, and then the y-axis is cells. So it's not like they're comparing degrees with degrees. We don't have to be so specific on that, okay? So I can see here that temperature, degrees Celsius, yeah, that's where we want to see where the 21 is. And it should just fit right between 20 and 22, of course, right in the middle. This is where 21 degrees would be. Now, I'm going to do this, although probably not so well, but all I'm going to do is just kind of show where 21 degrees is going to fit on that orange line right there. So not a perfectly straight line, but I don't really care because I get $30 of leeway on this in either direction. It's a really $60 interval. Now there's the blue points on this. This would be a scatter plot, and then this orange line here is what we would consider the line of best fit. So this is the first time we're seeing this in action. Once you get a line drawn for your line of best fit, you pretty much get to erase the points. Okay, so even though you're seeing those blue dots, those blue ordered pairs, ignore them because we have the line, which should tell you something about data and how it's used. But this is the point right here that I'm going to use as the cells. Okay, so I know it's 21 for my x value, right? And so I can already fit this in here. I know it's 21 for my x value. I just got to figure out its corresponding y value. So what I'm going to do is I'm just going to draw me kind of a line over here, and then pretty much estimate where that is on my cells. Okay. So for me, I'd say perhaps 450 would be about right here. We can see it's not quite up to 500, right? That'd be too high. It's certainly not past 500. In fact, for me, I would say that pretty much falls right in the middle of this green market, $450, and then 500. So for me, I'm just going to say that the cells would be at 475. Now, when you do a problem like this, you may say 460, maybe even 480. And if you really want to be super technical, I don't know, 476 and 23 cents, okay? The truth is that it's not going to matter on Canvas because, remember, it gives us a $60 interval there. But again, you shouldn't be putting something like 450 here because it's way beyond the halfway mark between 400 and 500. And it's definitely not up to 500, so you see how it kind of fits in that interval one way or the other. Yeah, in a statistics class, they would say, look at all these ordered pairs, now figure out the actual value, because they would say you can actually formulate, which Excel will do if you have the numbers, but you can formulate the function and then just plug it in that way. So my final answer here for me, $475, looks like. But again, you have a huge range to put in there. Like, as long as you're not putting like 400 here, Canvas will give you credit. And as long as you're not putting like 600, 700, for heaven's sake, don't put like 2 million. That'd be really bad. But maybe you'll have a good career as a politician someday. Data on tuition and mid-career salary are collected from a number of universities and colleges. The result of the data collection is this linear regression model. It's just, whenever you see linear regression or linear modeling, again, that can be in this form of an equation or function like this, okay? And they did tell us right here, x is the annual tuition, f of x, that's our y value, is the average mid-career salary of graduates, both in thousands of dollars, by the way, okay? So when we see a number, we need to remember to put that in thousands. So this 164 right here, it's already in thousands right there, okay? And even the negative 0.89, that comparison of rise to run would be in thousands of dollars, wherever it goes. And hopefully you know where it goes, but we'll see. According to this model, what is the average salary for a graduate of a college or university where the annual tuition is $72,000? I don't know, that seems kind of high to me, but I know there are colleges that do it, or universities. What is the slope of this regression model? We'll do this one first, okay? So, let's move this over so I have some space to work. Let's just copy the function here first. So I'm going to do this in the top right, and then we'll work from there, okay? So we got f of x equals, let's see if I can fit it, negative 0.89x plus 164. Well, there we go. And I do give myself a little space between the x and the plus because it's the x that we're replacing. How do I know that we're replacing x? Because it's the annual tuition right there, 72 grand. And x up here said it's the annual tuition, okay? It's just when I use x right here, I'm not putting x in as $72,000 because remember, the values, and you're going to need to remember this because this is a common mistake we see not only on quizzes and tests, but homework as well. It's already in thousands of dollars, so how many thousands is this? Just 72,000 right here. We don't need the 3 zeros on that, okay? So when I replace x, I am going to replace it with just 72 and not 72,000. So let's go ahead and do that. And I'm replacing the x in the f of x as well because, well, notations, all right? So there's our 72, okay? So this sets up the function to solve. And whatever value I get, it's also going to be in thousands, so I may have to reconvert that back into thousands, okay? Let's go and take to the calculator here, negative 0.89 times 72. And just from this, from order of operations, right, we get negative 64.08. And then I will add 164. So let's go ahead and do that, plus 164, enter. And, you know, if you can do all this stuff in your head, that's pretty freaking awesome. I just can't do it. So f of 72 equals, that's positive 99.92. But again, we have that. It's just we got to reconvert that. That would be in thousands, right? Now, for me, if I wanted to convert that into thousands, you could say just multiply it by 1,000. I would say just move the decimal 3 times, fill in any spaces with zeros. It doesn't really matter. You're going to get the same answer either way. So it looks like tuition in dollars here, $99,920. So that is, that's not the tuition, I'm sorry. That's the average salary. There we go. This is where we go back now for the slope, right? And we got to look at the coefficient of x, which is negative 0.89. Now, if I remember right, on the homework, it just wants you to write negative 0.89. And it's possible it may ask for the label on this, right? And so, once again, we compare rise to run on this. Let's see if I can fit this in here. Yeah, and you could put it over 1 if you'd like, but I think on the homework it wants you just to select one of the option that would be correct. And we know, like you're saying, the y value here is the f of x. That's the average mid-career salary. I don't know, I'm just going to put mid-salary because writing. This one's not asking for the explanation. It would just ask for a label on this one, yeah. And then the X for the denominator there, label, which is annual tuition. Maybe I shouldn't have used the same color. But yeah, something like this. Now, how would we describe this, right? Well, you'd say the average mid-salary, the average mid-career salary of graduates, if you were to describe it, now that it's asking for that, you'd say it goes down, looks like $890. As annual tuition, looks like it increases by 1. That'd be 1 in thousands. So if your annual tuition increases by 1,000, your average mid-career salary would go down $890. So yeah, if by chance you do replace X with 72,000 right here, you're going to get a ginormous value, which would, if it were in thousands already, you're looking at like millions of dollars right there, okay? Now, along the same lines, I know it's not asking for this, but the Y-intercept on this means that it looks like if your X, annual tuition, if it was $0, that means that your average mid-career salary would be $164,000, which should, I think that's fairly accurate, by the way, which should make you ask questions. Alejandro is selling HDMI cables on eBay and is trying to determine the best price to sell at For the last 10 weeks, he has adjusted his price slightly each week and tracked the number of cables he sold. He plotted the results and drew a line he feels fits the data well. And I'd say, hey, Alejandro, you did a great job, by the way.
Oh.
So the line of best fit passes through these two. So, yeah, it goes through these 2 points, 3.50 and 280, and then 4.75, 240. Find an equation for this line. So remember, and we talked about this before, there's only two things you need to write the equation of a line. This one specifically, it didn't really say it, but it will want this in slope-intercept form, y equals mx plus b stuff. That's exactly what I'm going to do. So I will use the slope formula to find the slope. And then, of course, we will still need the y-intercept, and there's a couple ways to do that, right? So slope formula right here. And I'll say the first point, we'll just say there's x1 and y1. So x's go in the denominator, y is in the numerator. So the x value is 3.5. You can put 0 there if you'd like. And then the y value, 280. And then we're going to subtract the second ordered pair, which we'll say is x2, y2. Barely fit those. And so the x value, 4.75, that's in the denominator. And then the y value is 240 in the numerator. Now you're welcome to calculate this on your own, but I am just going to put this into my calculator. Let's see what we get. So the n over d button, 280 minus 240, all over 3.5 minus 4.75. Enter, and I get negative 32. This right here is my slope. Okay, so there's my slope using the slope formula. But the next thing I need is the y-intercept. Now, I think we talked about point slope form. I'm partial to just using slope-intercept form, which is fairly easy to do. So you could say y equals mx plus b. It's possible that you guys went over this with the sub, but there's a different method to use. So remember, in this slope-intercept form, b is the actual y-intercept. We just found the slope, by the way, so I can replace the slope there with negative 32, right? Now, the other thing we see is that we got two ordered pairs that we can choose from for the x and y values in this slope-intercept form, because x and y are x and y values in an ordered pair. You can use this one, you can use this one. It's not going to matter. It will give you the same y-intercept both ways. And I'm going to use the one in orange there, the x2, y2, just because it's, I don't know, closer. So the x value there is shown as 4.75. Fit that in. And then the y value is 240. Okay, so this becomes an equation that you can solve. And you can kind of create your own formula for this, which I think was supposed to be in the lesson, but, you know, whatever. So I do negative 32 times 4.75. Enter, and I get 152, negative 152 there. So now I got 240 equals negative 152 plus b. And then it's just, again, it's just an equation that you're solving for b here. Just add 152 to both sides. So yeah, the calculator will give that to you as well. 392 equals, this zeroed out, drop the b. B is 392. Now you can put that in ordered pair if you'd like, but remember, we're just solving for the actual function on this one, or equation. So it says to use Q of P. And that means that P is the price. That's going to be our X value, right? So it's kind of like y equals MP plus B. Just using a P instead of an X, and then plus B, right? So we just found both values. We know that the M is the slope, which is negative 32. And then the B value is positive 392. And that right there would be considered the function for this line that Alejandro has drawn. I think there's a part B to this, but of course we should be able to interpret the slope and the y-intercept, because this is a word problem. They gave us both the labels for the x-axis and the y-axis on this one, and as well as the words in the problem there. All right, so same problem, but just part B, right? Using this model, predict the number of cables Alejandro would sell at price of $3.65 to the nearest whole cable. Let's go back and retrieve that then. All right, so it says we want to know how many cables Alejandro will sell if he has a price of $3.65. That's P for price on this one. And so I'm just going to go into this equation that we have and replace P with the price that it gave us, $3.65. So let's put this in here, $3.65 there, that P, and then this P as well, $3.65. I'll do this one in green. And again, from here, we're just pretty much just solving this at this point. I didn't want to do that. I do want to do this. Maybe it's still kind of sloppy, but negative 32, let's put this in the calculator, negative 32 times 3.65. Enter. Yep, and then you just add that to 392. So, yep, 275.2. So that's the Q, right? Quantity, Q for quantity, I suppose. Now, it did say to round to the nearest whole cable, so you could say, well, I mean, you'd hope that it'd sell an extra one, but I mean, it's going to round that down because of the 2 into just 275. And this one, by the way, it is a word problem, so I'm going to go and label this 275 cables on this. So a hospital has been tracking the number of incidents of heart disease it treats each year for several years. The data is shown below. The data is approximately linear. Use the data from 2012 and 2015 to find an equation for a linear model. And again, since it's asking for an equation here, we are looking for slope-intercept form. So the only two things we need is the slope and then also the y-intercept. Now it does say that year 0 here should be 2010, right? So you'd say, well, 2011, 2010 right here, but we just don't know what those values are, although we could kind of figure those out. Now, it did say also that we just want to look at 2012 and 2015 to make this conclusion, okay? So that means that I'm going to go in here, and I just pretty much need to ignore these two values right here, all right? Is it always going to be linear? No. But if things stay approximately the same, then it should be approximately. You should see a rate of change that stays approximate, okay? So that means that we're looking at two ordered pairs right here. This would be 2012, 74, and then this one would be 2015, 92. And since we only need two things to write the equation, one of those, of course, is slope, and we just found two ordered pairs that we can use on this. So I'm just setting up the slope formula right here. I'll say that this is x1, y1. So putting these in, the x value is 2012, and the y value is 74. And then we'll say this other point here is x2, y2. Okay. And remember, the order doesn't matter because the slope, the steepness of the line won't change. The x value, 2015, and the y value, 92. Now, if you're wondering how I know that the x values are the year and the y value is heart disease incidence, because the x usually is always going to be time, and years is still a form of time. So this now, we're going to go and put this into the calculator. Yep, so the slope here, yeah, it is, see if we can get this to work there, 6. Now, again, this in context would indicate that it increases 6 incidents every year, or for every year you get approximately 6 heart disease cases. So the slope, there's our first thing that we need, and we found it. And so the next thing we need is the y-intercept. Now, there's a couple different ways to find the y-intercept. I used slope-intercept form to do it last time we saw it in a problem. I'm going to use point slope form, which would have been part of 3.7 on this one, which shows, at least the way that I do it, y equals mx minus the x value, and then it's usually plus the y value. So the m value here, and then we'd have x value and a y value here. All right? So in green, I'm going to use the x1 and y1 values just because I already made them green. But we do know the slope already is 6, so I'm going to replace m. M is always slope. M was 6 right here. And then the x value in green there, if I can choose the right option here. I forgot one thing on this, actually. So 2012 is not actually the year. Now, it will still work with the slope, by the way, but for the Y-intercept, it's not going to work. Because they say that 2010 is year 0, which really means that the year would be year 2. So 2010 is 0, 2011 1, 2012 is 2 on this. So it really reads as 274 like this. If you put 2012 into point slope form here, it's going to give you something that's really jacked up. Always be aware, I mean, that's what I just forgot right there, right, is that it's always relative, and it'll tell you how relative it is right here, like 2010. So the X value is 2, and the Y value is 74. And then all we're going to do now, and this is not really solving for the Y-intercept, although it pretty much is. You could say, look, we're going to go ahead and distribute here, which is true. 6 times x is 6x. 6 times negative 2 is negative 12. Then you still have the plus 74, right? So negative 12 plus 74, that'd be plus, looks like 62. And just to make things look pretty, there's our slope as 6, and then 6x. And I guess they did say to use n of t right here, so that's what I'll do. N of t, which means the x value is a t, the x is just a t. T for time, of course. So there's I don't really need parentheses. 6t plus 62, and this would be the linear model for this situation, at least between 2012 and 2015. So just so we see this other ordered pair translated, 2015 would be the 5th year, and then the number of heart disease cases is 92. All right, so this also means if you went back to the slope formula, by the way, and you put 2 and 5 right there, yeah, it will maintain the same slope. All right, same problem, part B, using the model predict the year. All right, let's go back and get the model then. All right, n of t equals 6t plus 62. Sorry, my t's look like plus signs. But it says, using this model predict the year, that's t, by the way, t for time, in which the number of heart disease incidents, that's the n of t, oh, dang it. N of t, there we go, will reach 146. That means the n of t here needs to equal 146. So I'm just going to replace n of t, the y value, essentially, with 146. And then I'm going to solve it for the t on that. So 146 here. So this just becomes an equation that we need to solve. So let's go ahead and do that. I would first subtract 62. I just want to isolate those t's. So that'd be 4 and 84. So that's going to equal 6 t's there dropped. And then, yeah, this zeroed out the 62s. Last thing is just divide both sides by 6 to get just t. So the amount of time it appears would be 1 and then 24, 14. Now, t is 14. It did ask what year this would be. It wouldn't be 2014, or it wouldn't be year 14 either, by the way, because remember, year 0 was 2010. So it's really 14 years after 2010. So you could just take that 2010 and add it to 14. Then you would have your answer for the exact year, or approximately, which should be, 2024. So you have to be aware of what the starting value is, or, if they're changing values, is it thousands, maybe millions, even hundreds or something like that. You got to be careful. And you'll see that I've been reading these kind of word for word. I've been trying to, because one of the things I struggle with word problems is just kind of skipping over stuff. And then I calculate something, but it ends up being the wrong thing. So make sure you read it. And if you're not really sure what it is, reread it. You may have to reread it several times, in fact, before you really figure out what it is that you're trying to solve for in the first place. So suppose you have $215 gift card for gas. You spend on average $19 per week for gas. Write a function to model this situation where W is the number of weeks and G of W is the value in dollars remaining. And again, the G of W thing, that's Y, and then the W here is our X, if you're looking at it that way, okay? Now, the nice thing about this is if we can just remember that slope is rate of change, right? So I'll write this out. Slope is rate of change. then you would notice on in the word problem, again, it may take several readings, but they gave us a rate right here. It's $19 per week right there. Now, the other thing about the 19 is it's dollars spent. So right there, I can see that my slope is negative 19, okay? Because it's already shown as a comparison of two values, dollars and weeks, and it's spent, so it's negative. But in addition to that, they've given us the Y value as how much you're going to start with, which is a $215 gift card, right? So most students, I think, would write it like this. It's a $215. This is what you start with, and then you're going to spend $19 every week, and the W, of course, would be the weeks. This is what would be G of W right here. So this is one way to do it, and I believe Canvas will accept it, by the way. Is this formal slope-intercept form? No, it is not. But it doesn't have to be, I think, on these word type problems. You could have also written it, and this would be the same. It would give you full credit in formal slope-intercept form, which would have been negative 19W, and then a plus 215. Again, I think the first one is more practical, just because most people would say, yeah, I know I'm starting with $215, I'm spending $19 per week, and then that would tell me how much money's left on this card. All right, G of 7. So 7, this would be 7 after 7 weeks, how much money would be on the card, assuming you spent $19 every week. So let's go ahead and just write this out. I'll use the first one because, again, it seems like it's more practical. Starting with $215, you're going to spend $19 every week. Right now, we can see that the number of weeks it wants is 7. So I'm going to replace the W here with 7. So, order of operations kind of stuff. You're welcome to just put that in the calculator, though. But 19 times 7, I get 133 there. So, yeah, the last thing here, just do that subtraction. So 215 minus 133, 82. I think I can fit that in there, 82. So after 7 weeks, it appears on this card, and that's a G of W, but it's a G of 7. After 7 weeks, you'd have $82 left on the card. Sorry, that's kind of small. I thought I had less space than I did. $82. Yeah, we should label this, by the way. What's the value in dollars? It even asked for it right there.